All right, before Chinese New Year break, we stop at these slides. Let me close the light, guys. Okay. Let's look at how to apply. I think we haven't go to this example, right? How do we apply the things that we learn these three equations? So let's say you have a balloon, weather balloon tied to the top of a building, and you're given the original axis, which is x and y, and this balloon will have an elastic rope or chain. They're able to extend at a certain distance after a certain time. You're given y equal to x squared divided by 5. So for this module, you deal with three types of graph: linear graph, quadratic graph, and exponential or log graph. Okay. So as you can see, this one is quadratic curve. Okay. Now quadratic curve, y equal to mx, y equal to ax squared. If you have quadratic curve, y equal to ax squared plus bx plus c. If your a is positive, the graph will be smiling face. If your a is negative or less than 0, your graph will be sad face. Right? So from here, you know that from the equation itself, it is part of the smiling face. Right? So when it comes to final exam, sometimes the diagram won't be given. So you need to predict the type of motion that happen in that particular setting. Then you'll be given a formula. Most of the time it's quadratic equation. So you need to predict the motion. You need to know how to draw the path for the object. So if you refer back to the question, so you're given the weather balloon, it moves in x in such a way that in a linear form, which is in 2t, x equal to 2t, means every second it moves in this direction. And the y is given here, y equal to x squared divided by 5. So you have two directions, means you have two vector form. So determine the magnitude and direction of the velocity and acceleration when the time is 2s. Now, for engineering dynamics, you have a certain way of solving problem. Step one, always mark your axis or coordinate system. In this case, we will mark x and y. Second one, you will draw your x and y, and then you draw the necessary axis. In this case, you haven't seen anything yet, but later we will have axis at step 2. Then 3, you put in the formula and you analyze. Okay, so how do we solve this one? You pull the definition of velocity, acceleration into this solution. You have y, you have x. So you know that velocity previously you can do in 3 axis, which is I, j, and k. You know the velocity is dx, dt. Y is y direction is dy, dt, and z dz, dt. In this case, you don't have z. It's a two-dimensional problem. So z is cancelled. This is a differential equation. Dx, dt is differential this one. Dy, dt is this one. Okay. Now let's do a revision for your differentiation. If you do dx dt, what do you get? Patrick, what do you get? 2. Okay. Then this one, Patrick. Huh? 0. Okay. Anyone? You need to pull your, this one, x, no t. But is there any t represent x? Yes. You need to substitute your x here. It is 2t is here. 2t squared. It means 4t squared. So 4t squared, you integrate, what do you get? What do you get? You understand what I'm saying? Yeah. Y equal to 1 over 5x squared, 2t squared. Yeah. Okay, so get something, huh? So is it correct? So you need to be careful on the information you have, huh? Right. Again, in all the example that we give you, don't chase after the numbers. Differentiate first. Means you differentiate this one. It's not the correct way because you are taking out the t form. If you this is some, if you dy dt, there's no t, so you get 0. So 0 is not the correct equation that represent the motion. Okay, so just be careful on that. All right, so you do the time differentiation. In x direction, you have dx dt, so you get 2. The answer for Vx is 2 meter per second. The direction, because you're dealing with vector have magnitude and direction. 2 meter per second is speed. Speed is magnitude. Vector, you have magnitude and direction. Direction is to the right, positive. Okay, so this module, you need to always define where is your positive direction. Your arrowhead will represent the positive direction. Sometimes you forget to put the plus is okay, but you must mention where is the arrowhead, your arrowhead for your axis. All right. Then y direction, remember to substitute your x value there. Okay. Don't rush into solving the question. Then here you will get 8 over 5t. Okay. Then the direction is going up. Okay. Now something interesting about vector, you can link back to your trigonometry or right angled triangular. Let's say this is a starting vector A, starting vector B, and to draw the resultant, you always start with beginning and the end of the motion. It will bring you resultant, I name it as C. So to complete this vector equation, C vector equal to A plus B is vector, is vector. And in mathematics also, you want to find the magnitude of C. What you do, you square root A and you square root B. Right? So this is a fundamentals there. And from the same idea, you can find the angle between the vector. This one you call in tangent theta, sine theta, cos theta. Tangent theta, opposite side, B, A. Sine is side and hypotenuse. Cos, B, sorry. Sine is opposite and hypotenuse. Cos is A divided by C. Okay, so this is can say as a cheat code for you guys when you solve problems. Okay, so it's important. You draw somewhere in your answer sheet, it will help you to solve a little bit or see the question more clearly. Okay, since we have two directions, and then these are general equation, and when the time of 2 seconds, you just substitute the time. So y is 3 point something meter per second, still going up, right? So magnitude is using square plus square root. You find the magnitude. So you need to use this equation. V equal to square root of Vx squared plus Vy squared in your solution. And when we come to assessment, test 1 final exam, don't use your own notation. Don't use P, Q, or something that I did not use in the lecture. You can use, but you have to declare, or you have to write it clearly. What do you mean? If the notation or the alphabet or parameter they use I do not mention it in my lecture. Okay, yeah. So the reference answer for you is 3 point something. Okay, so you go to the balloon there, you draw the x vector, y vector, you draw the x vector, y vector. Then you know that when you have two vectors, they always have a resultant. Resultant is a vector. Vector have magnitude also and direction. So still go back to what I write on the whiteboard. Find the magnitude of the resultant. You find the angle of the things. All right. So to find angle, what you do? You just inverse the thing. Right? Theta equal to tangent. You press calculator, and you get. Same with others. Okay. So the answer for you guys for the angle for velocity resultant will be 58 for this example. Okay. Try to understand the solution, the procedure rather than the numbers. Okay, and the logic behind why we use this equation. All right. Do the same for acceleration. Acceleration, you have A equal to dv dt, time differentiation of your velocity. You have two equations previously, Vx and Vy. Vx, you get 2 meters per second. Vy, you get 8/5t. And Ax is dv dt in x direction. You look for Vx in x direction. When you differentiate constant number, what do you get? 0. 0 means there's no change of velocity. No change of velocity means acceleration 0. Okay, so you get 0. Be careful on the unit. Unit is meter over second square. On the y also dv dt, but in y component, you'll get 8/5. Okay. All right. Then you do the same to find the magnitude and direction for your resultant acceleration. Square plus square root. Okay. Then find the angle of your acceleration. Okay. Reference answer for the magnitude of your resultant acceleration will be 1.6 meter over second square. What else? Then you go back, you can overlap your diagram. Just now you draw velocity. You can overlap and add in AX and AY, or you can redraw a new one by adding AX and AY. You know that your AX is 0, so there's no vector in X direction. That's why I use dot arrow. Okay, to remind myself that actually there's no vector, but in X direction. I only have Y in this case. So no matter how I do my magnitude determination with the square plus square, my x0, my y have some value, and square root, I still get back the answer, 1.6. Okay, so my resultant acceleration will be going up. The answer is 90 degree. 90 degree referring to where? referring to your x-axis or horizontal axis or ground level. Okay, any questions so far? Make sense to you? Important is the solution. It should make sense to you. If something doesn't make sense, then there's the issue or there's the area you don't understand. Okay, I moved it very fast. So you put in there and label as A. This is your resultant. Okay. Another one. See if you're able to solve. So this one, you have an aircraft takeoff from the runway. So you're given an aircraft takeoff from the runway with a y change with time, change with x 0.001 x squared. You know that this is again quadratic equation with positive a. It's a smiling face, but a shallow one, right? Because it's a is very, very low. So you have a smiling face curve. If the plane rising with a constant upward velocity, you are given 10 meters per second. So you know that upward, what I mean by upward, if you refer to the axis, upward is your y direction. So you have your Vy equal to 10 meters per second. This is the information you have, right? Now determine the magnitude of velocity and acceleration of the plane when it reach altitude y equal to 100 meters. So you want to look at the situation when you reach 100 meters. So how do you do? Again, same, recall the definition of velocity and acceleration. And then you do integration. No, then you do the substitution and so on. So on the graph, you draw 100 meter just to help you to illustrate the things. And 100 meter is y. So you can find your x location, right? At 100 meter, you can find your x location. You substitute your y here, and you have a square root answer. Square root, you always get positive, negative answer. Choose the positive one. Why positive? Because your plane or object or particles move to the right, and you define right positive. Okay, if you give x is negative, means it's go back, go to the left-hand side of the graph. Okay. So you have this one, Vy, you already have, right? Some numbers that you can extract from the statement. Then you find your x, you substitute your y, you do the square root calculation, you take the positive root, you get 300 something. Remember to carry the unit, which is in meter. So on the graph, you update the x coordinate. So you know that your y, how you find the y is take velocity multiplied by time, right? This is a hidden information, by the way. You do not mention in the things, but it just tests you some simple logic. How do you find position? Position by using the velocity given. You take velocity multiplied by time, you get position, right? So you can find the time when it reach 100 meter because you have a vertical velocity, right? You have vertical velocity. You need to find what happened at 100 meter. So time is a very important parameter. So you substitute y100, Vy you know is 10. Missing out is t, you know from here, t is 10 seconds. So you find another important data, which is the whole motion stop at 10 seconds. Right? All right. So once you have all this information, you continue to solve lah. Again, you need to use chain rules. Go to Canvas, download Appendix C, again, is a vector chain rules. So I assume you already know. So because we are not dealing with mathematics here, so I assume you already know. So this is a chain rules, means you integrate the rules. So v equal to dy dt in y direction. So you integrate this one, you get, you need to do chain rules, huh? Why chain rules? Because inside here, there is no t here. Inside here, there's no t here. So you need to use chain rules. For example, for previous example 6, you can continue to solve by using chain rules if you do not have any information on the x value. Okay, so the chain rule is a solution for the question raised by your friend just now. Can you continue to do? Yes, but use chain rules. All right. Why chain rules? Because again, there's no t inside the equation. So chain rules means you solve for the y, you rewrite the equation dy dx, dx dt. So actually you are cancel out the dx, you still get dy dt. But you split it into 2. So you do dy dx first. This is dy dx. Dx dt is another parameter. So you do what you can first. You differentiate y on x. You get one equation. Then you left out the dx dt. This one might seem complex to you. You can continue to use dx dt, but I will put as vx because I'm dealing with velocity here. So I just simplified the parameter that I have, or missing parameter that I have. So I get one linear equation here. I get equation between relationship between my velocity in y direction and x direction. Okay. Then you substitute your vy. You have your vy, right? Vy is 10. You know that at 10 seconds, your x is 300 something. You substitute here, left out one your vx. From here, your vx is 15 point something. Okay, so example 7 is actually recalling your vector or chain rules understanding. Okay, then you go back to the diagram, draw the vector. Vy is going up, Vx going to the right. So you have two vectors, solve the vector resultant. Okay, so solve the vector, you draw the vector diagram, you find the angle, you find the magnitude, and you solve the question. Okay, so I'll just give you the answer. So V vector magnitude is 18 point something. For this module, minimum 2 decimal place, maximum 3 decimal place. So this is just an example to guide you through when you do your revision. So the direction is tangent. Anyone don't understand why it's tangent? Why is tangent? We use tangent equation. Anyone don't understand? Okay, because you have two vector here. Vector to the left, which is your A that are right on the whiteboard. Your Vy is your B. It form a 90-degree triangular. Then you can use this one. And sometimes, as you go deeper, you need to dig back your cosine rules, which is cos square theta something, sine square something. That one. Okay, the parallelogram triangular. That one later. We stay at chapter 1, so we go very easy for you guys. Later, you need to recall back the trigonometry chapter, which is not right angle triangular. Or this you have a triangular shape, but not 90 degree. And then you need to use back the cos square something, the equation. Right? Okay, so you update the graph, you find the angle. So reference answer for you is 32 degree. Right? 32 degree. Acceleration, so still the same. Still the same. Acceleration, call back the definition for acceleration. Acceleration is time differentials of a velocity. Just now you have velocity equation that you derived from section A just now. So Vy equal to 0.002x Vx. So again, you use back chain rules. You use back chain rules. Why? Because this equation do not give you, there's no t inside here. So what you do, you do the chain rules, d dt uv plus u dv dt plus v du dt. Means u means the first term, v means second term. You just use this general equation, you substitute, then you do. You freeze the first one, you differentiate second one. You freeze plus, you freeze the second one, you differentiate the first one. Okay, this you learn in your mathematics. So to use these rules, you need to have a condition or boundary condition. You let your u equal to 0.002x. This is u. This is v. Right? U and v. Then you use the general equation. Right? So stop me if I go very fast. So d dt uv. This is u, this is v. Then you follow the equation. This is u. V is what? V is integration of your, this one. dvx over dt, what you get? You get acceleration. Make sense? Then you do the same for the last part. Vx equal to du dt. So what is your u? Your u is this one. All right? 0.002x. You differentiate with time. X is a position. Position differentiate with time, you get velocity. That's why you get Vx here and not x. Okay? Then you continue to solve. You rearrange your equation. It's the same constant value. You pull out, then you get one equation there. Then how you solve? You solve by using graph method or coordinate method. You have your x value, vy value, ay value. This is a hidden information. When you have a constant vertical speed, means acceleration in y is 0. This is a hidden message. Okay, so once you have this one, you substitute inside here. You have this value 0. You have ax. You need to find vx. Need to find. So okay, you substitute the value. Okay, x value you have. Vx you find just now in the earlier section. You substitute, you solve for your ax. You will get negative sign. What mean by negative sign? What mean by negative sign? Deceleration, deceleration. Okay. So just call back what you get, and you get the magnitude. You have your x and you get your y. So again, what is the value of your y? 0. Why 0? Velocity constant vertically. That's why y is 0. So square something value and square root, you still get back the same answer, 0.79. Direction, go up, 90 degree. Sorry. This is your y, okay? Going this way. Okay. Okay. Later. Any questions so far? Why this one pointing here? Why pointing here and not here? Why? Also 180 degree, it depends on your diagram. My angle starting from here. Yeah, you can, but because my A is negative, I point in. Okay. You can put on 180 degree. Your diagram should show very clearly. Same also, 180 degree. Okay, 2 slides before this one. This slide is more on the chain rules. Okay, applying this green color formula. Okay, any question? Good. Okay. No question. We have a short break, or you can continue. Huh? Continue, Huh? Yeah, later. That one later. You guys can continue, or you want break? Break. Okay. You stop here. Yeah. Okay. Yeah. Hold on. Oh yeah.